Hello, my name is Emmanuel and I'm a data analyst in Oklahoma City. I've created a tutorial on how to utilize Python, the Pandas library, and the XlsxWriter library to perform advanced data analysis. What I'm going to be doing today is taking all of the information in this sales data folder and concatenating that into a large table, manipulating the elements within that table, and then exporting summaries to charts as well as to JSON files. I'm going to be creating heat maps for year and region, year and property type, year and month, city and year. I'll be making graphs that show the difference between profit and loss for each quarter, return on investment for each quarter, return on investment for each month, and return on investment for property type by quarter. Then I'm going to save everything to JSON grouped by the year, the regional manager, and the city rep. I'm mostly going to be using the OS module to navigate folders, the Pandas library, and inside that library are things like the merge function. I'll be using the XlsxWriter library to save my tables and my charts, and then the JSON library to write everything to JSON. First thing I want to do is show you one of these files here. I'm going to sort this by size. So the largest file is 174 kilobytes. If I open this here, this is a significant number of records. And we have 30 items, 29 text files in this folder. It would be cumbersome to try to import each of those text files into Microsoft Excel and perform data analysis that way. That's why I'm going to be using the Pandas library. So first thing I'm going to do is run this cell for my import statements, importing Pandas, datetime, the OS module, JSON, Seaborn, and the calendar module. I'm putting this here so that I can time how long it takes for this entire script to run when I'm finished with it. What I'm doing here is declaring a base path, and I'm storing that value into a variable. This is the path that I'm in right now. I'm in my data migration folder. So when I run this, I'm going to get this full path to my data migration folder. I'm declaring this so that I can add the names of any subfolders that I want to add information to later on. This function takes in a name argument, and it adds that name to the base path that I declared here. And then it creates folders with that argument. If it already exists, then it doesn't throw an error. But if it doesn't exist, this line, os.makeDirs, with this base path plus this argument here, will create a new folder in this current path that I'm using. And then it also returns the string for that path. So I'm going to run that. I'm going to call this here. Let's say we want to create a folder here called a sample folder. So I just call this function sample folder, and I can store this into a variable. We'll call this Q. When I run this function, it's going to create a new folder here called sample folder, as well as store the value of that path in Q without actually changing our current working directory. So I do that, and you see over here, sample folder was just created. And when I go to a cell below that, type in Q, and then it shows me that entire path, data migration sample folder. But when I get my current working directory, I haven't actually changed my working directory yet. So I'm still in this folder. There we go. This function getFiles takes in a path as well as an extension. Whatever the path is, we concatenate that to the base path, and then we change directory into that path. And then this function here, pd.concat, which takes in a list as an argument. And inside this list, is a list comprehension that's saying file for file in os.listdir if os.path.splitText for that file at index 1 equals this extension that we're putting in as an argument. Let me show you what this does line by line. So first, here's list comprehension. So let's say, first, actually, I'm going to change directory. So chdr into, we're going to this folder. So I'm going to copy that path. os.chdr into this path. And then when we call a list comprehension, x for x in os.listdir, os.listdir, it gives us all the files in this folder, right? We are now in this path, so we're getting every single file in this folder. And what we want to do is read in each file into a data frame. So we say pd.read CSV everything in this path. This is going to throw an error, however, because this is an Excel file and we need to read everything that either has a CSV or a TXT file path. So I'm going to run that. That throws an error. So what we can do is say pd.read CSV at x for x in os.list directory if os.path.file os.path.splitText at x at the first index equals .txt. Right, so now we get a list of each of these, the content of each of these files. So you can run pd.concat on this list, and it should return a data frame. And there you go. So in our 29 text files, we have a total of 28,784 records. So I'm going to delete this. This function does the exact same thing. And I'm going to delete this. In fact, I'm going to start all over. There we go. Let me just run that. Good. So we call it the get files, and we want it to go into the current base path, which is data migration. And then from data migration, go into the sales data folder, and then read everything that has a .txt extension. And now we have our data frame. There we go. Okay. I'm going to go back out here. And this is our, this is the reference I'm going to be using. It has 3 tabs on it. One for the city, the region in the city, the region and the manager, and the city and the city representative. So what I want to do is, okay, there we go. What I want to do is first concatenate a city region ref to my base path, and that's the file I'm going to be using. And I'm going to do p.readExcel this file path. When you declare sheet name equal to none, it does not read in any specific tab. It reads in all tabs into an ordered dictionary. And then you can use list comprehension to say tab for tab in ref returns the keys in that ref dictionary. And then when you say that dictionary at the tab key, that returns a data frame. So this is now a list of data frames, and you can unpack the list of data frames into separate variables. So city will be the first tab, manager is the second tab, ref is the third tab. When I run this, I'm going to show you each of the tabs. So city, manager, and ref. There we go. All right, so now we're going to groom and merge the data in the data frame with the ref tables. This function called city_state takes in a data frame, declares a state variable, which is the value in the state field, City is the value in the city field, and it returns the city, comma, the state. This is the data frame, and currently the city is just the city and the state is a separate field, whereas in the city table, the city is a combination of the city and the state abbreviation. So when we join those two tables together, we have to make sure that the value in the city for both tables is equal to each other. So I'm going to run this. So when you want to apply a function to a data frame, you call the data frame.apply, and then you put that function in. And because we want to apply this to the fields, we have to specify access equals 1. If you're applying a function to the records, you would specify access equals 0. And I'm going to call this function on this data frame and then set the value equal to our current data frame at the city field. Okay, no errors. So here what I'm doing is taking the city reference and applying a lambda function. So lambda x is an anonymous function. So we're saying for each x in this function, return that value as a string and then, dot upper. Basically, right now, everything in the city, as you can see, the city now has a comma in it. Everything is capitalized, whereas in the city reference, everything is lowercase. And when you merge things together, when you're checking for equality, you have to make sure that the cases are equal to each other. So when we run this function, it's going to take everything in the city reference and convert it to uppercase. We're going to run the same function on the manager table and the rep table. Okay, this function is called outer join. It takes in 2 data frames and 2 indices. And what we're doing here is setting the index of the first data frame to the string value. These are data frames and these are string values. We're setting the index of the data frame to this string value, which is a field in that data frame. And then we're doing the same thing in the second data frame. Then we're going to take the first data frame and merge it with the second data frame using an outer merge based on the index. So I'm going to show what this means. So this is our data frame, and this is the city reference. So we want to merge on city. So what we can do is say df.set index to city. We'll call this A, and we'll call this B. City.set index to city. Good, there's no errors there. So now you see these are now the indices of the data frames. And now we can merge these data frames with each other. So we can call a.merge. I'm going to copy this down here. We can call a.merge b, doing an outer merge. Left index is true, right index is true, meaning that you want to merge on the index. And this should return a data frame of the A data frame with everything from the B data frame that wasn't originally in the A data frame. I'm going to comment this out so I can show the difference. A currently has 5 columns. What we want to do is bring in this region column. So if this function runs correctly, we should now have 6 columns in A. Well, it currently has 6 columns. So now you have state, investment, revenue, and it's also have the region column now. And you can reset this index so that you can have city as a proper column instead of as the index. There we go. Actually, now we have 7 columns. Well, I guess that's what I wanted. Oh, I see. That's right. This has 5 columns because I reset that index. So when you reset the index, it takes the index and makes it a regular column. So df has 6 columns, but when we call this function, it should have 7 columns. And then we're going to call it again on the manager table as well as the rep table. So right now it has 6 columns, and we're going to be adding, I think, 1, 2, 3 more columns. We should have 9 columns after we run both of these two cells. So I'm going to delete this, run that, run this, and DF now has 9 columns. We've taken the regional manager, the city rep, as well as the region from the original, from the reference tables. So now our DF has been joined to those reference tables to get those other values. Here, as you can see here, the investment and revenue fields are strings. So when you try to perform a mathematical operation on strings, it throws an error. We have to convert these to floats. So you have to remove the $ and the commas, and then convert that string into a float. So you just take this function takes a value, you replace the $ with an empty string, then you replace the comma with an empty string, then you convert the value to a float, and you return the value. I'm going to call that function on investment and revenue, and then set the results of both of these function applications into those fields. So we're going to look at DF again, and you'll see that these are now numbers. The date field is a string, so I'm going to call a Pandas function called pd.toDateTime on the date field, and then set the results for that into the date field. So this is now going to be a datetime object. And then once it's the datetime object, you can apply a function that gets the value of the year, the month, and the quarter. So as you can see, right now, DF has 1, 2, 3, 4, 5, 6, 7, 8, 9. Hold on. Yeah, 9 columns. And once we run this, DF is going to have 12 fields. So DF now has 12 fields because we now have the year, the month, and the quarter from the datetime object. Here I'm taking the value of the revenue field and subtracting the value of the investment field to get the net value, the net income, and then I'm rounding that off to 3 decimal places. Here I'm defining a function called ROI. It takes the value in the net field, divides it by the value in the investment field, and then rounds it off to 3 places, and that returns a percentage that represents the return on investment. I'm going to apply that to the entire data frame on axis 1, so I can apply it field wise. Here I'm taking the ROI field that we just created, and I'm going to show that here. These are all return on investments as a decimal. And what I want to do here is say if for each value, in every row, return the word profit if that value is greater than 0, else return the word loss. And then the result of that series is going to go into a new field called profit loss. Okay. Here I'm defining a function to generate a heat map. It takes in a data frame, some indices, a list of columns, a value type, and an axis type. The value is what you're going to be aggregating, and the axis defines whether you want to see a correlation on the columns or on the fields. So in order to get a heat map, you have to call a function called pd.pivotTable. It takes in the data frame that you're aggregating. The values equals whatever value that you're trying to aggregate. In our case, it's going to be a return on investment. The index is equal to the list of indices. The columns is equal to the list of columns. And then we're going to round that off 3 places. This returns a Pandas table. You can convert that Pandas table into a colored style object by taking that table and then calling it style.background gradient method. The CMap is going to be equal to the Seaborn library that I imported earlier, the .light palette, and the argument is going to be whatever color you want. And then as CMap equals true, and the axis is going to equal the axis that you want to concentrate on, whether you want to see the correlations between the fields or the correlations between the records. So your x-axis or your y-axis. And then after you do that, you want to return your heat map. Here I'm defining variables that are calling the heat map function. Each takes in the original data frame. There's a list for each record, a list for each field, and then the value for all is going to be return on investment. The first three are going to be concentrated on the correlation between the fields, and the last one is going to be concentrating on the correlation between the records. I'm going to show these. All right, so that's one of our heat maps. And as you can see, the darker areas are going to be larger and the lighter areas are going to be lighter. So here we can see there's a decreased return on investment in California, New York, Oakland, Orange County, San Diego, and everything else seems to be a darker green. You can also see the heat map for the year month. This one's correlating based on month, and you see that there's a higher return on investment for the summer months. We're looking now at property. Looks like there's a deeper correlation between a high return on investment for residential property versus, say, commercial, industrial, or land. And then we're looking at region. And yeah, just like the other one we saw, California seems to have a lower return on investment than other areas of the country. This function returns a pivot table that is going to serve as a reference for a graph. Here I'm taking a subtype. The subtype just tells you which different pivot table or group by object that we want to return. I'm declaring a dictionary here, and then I'm saying for each year in the list of unique years in the data frame, and then for each unique region in the data frame, we want to declare a data frame that is equal to that year and equal to that region. And then depending on the subtype, we're going to be grouping 4 different items. The first one groups by the quarter and the profit loss. This returns a count for profit versus loss for each quarter, for each region, and for each year. The second one returns a pivot table that shows the cross-section of each quarter in each region and the average return on investment. The C returns a pivot table for each month in each region, and then it aggregates the average of the return on investment. And the last group by object aggregates by property type the average of the return on investment. And then you take each year in each region, and that serves as the key for the dictionary, and you store this data frame, whichever, depending on the subtype, whatever that returns, you take that summary object and you store it into the dictionary, and the key is going to be the year and the region, and then you return the dictionary. Here I'm defining a function that inserts a table, takes in a dictionary, a writer object, and a title. The first row is going to be 0, and then for each item in the dictionary, you want to take the key in the dictionary, and whenever you're, how do I do this? Okay, so here's a dictionary, And A is the key, and the value is 5. And B is another key, and the value is 10. In fact, let's do this, yeah. Okay, so that's a dictionary. And then you can get a value in this dictionary by placing a key into a bracket, and it gives you the value at that bracket. There you go. So what we're doing here is saying for each dictionary in this list, put the key into the dictionary, and that returns whatever is the value of that key at that dictionary. In this case, it's going to be a data frame. Then we're going to take the first column of that data frame to get the length of the column. And then we're going to take that data frame and write it to Excel with the writer object. The sheet name is going to be the title that we place inside as an argument in our function. The start row is always going to be here, and the start column is always going to be 0. And when you get to the end of the loop, you increment the row by the amount of the row currently, the length of the data frame, and then 2, so that you can have space, and then you have the start of the next row. This behemoth has taken me quite a while to figure out. This is the Pandas XlsxWriter charts documentation online. I'm going to include it. In fact, I'm going to copy this right here and paste it here. It's taken me about a year to figure this out. What this code does is it takes in a dictionary, a worksheet, a workbook, and a sheet name. And for each item in the dictionary, the key in that dictionary, the key is going to serve as the title for the chart. And the value of that dictionary is going to be a summary data frame. And what we're going to do is reference one of the tables we create here, and then take the data from that summary table and use it to populate a chart. So you're setting a chart list equal to an empty list. First row is always going to be 1. Column is going to be equal to 0. So for each item in the dictionary, the title is equal to the key, and then the data frame is that dictionary at that key. We're getting the series length, which is the data frame at the first column, the length of that column plus 1, and then the row length is going to be the data frame dot index. I think I have that backwards. I think this is the row length. No, I'm not sure. All I know is that this works. It's taken a lot of painstaking research to try to figure out what's going on here. But basically, you're calling a chart is going to be the workbook argument that you put in dot add chart. The type is going to be column. And then for each column number from 1 to the series length, you're going to call the chart.add series method, and the name is going to be the sheet name that you call up here. The columns is going to be the column that you start with, which is 0, and the column number always starts at 1. The categories is going to be the sheet name, the values. Oh boy, I gotta be honest. I have no idea how this works. I just know that it works. Most of what I understand comes down here. All of this has been painstakingly added bit by bit over the last 9 months or so. And I honestly don't know how it works. All I know is that it works. But here you call the chart.setSize method. The width is going to be 700 by 477. And then once you have your chart element, you append it to the list that you create up here. You increment your row by the row, the R length, and then 2. You increment your columns by columns, the R length, and then 2. The row number always starts at 1. The count always starts at 0. Here's where you're actually inserting the chart into the worksheet. You have to define a cell dictionary. Each key is 1 through 7, but each value is going to be an Excel column. So Excel goes all the way from A through whatever. And because this chart is 700 by 477, you have to basically space out to where the first chart starts at A and then it ends right before L. and then the next one ends right before W, and the next one ends before AH, so on and so forth. So for each item in the chart list that we have, we're going to increment this count by 1, and then call the worksheet.insertChart function, and we're inserting the chart at this cell dictionary at the count. Currently it's 1, so that returns A, and then you add that to the row number, which is 1, so that it adds the first chart to A1, and the chart that you're adding is what's in the chart list at the current index, and then the scale is just 1 by 1. If you increase this number, it would increase the chart size. If you decrease it, it decreases the chart size. So as we're going through, if the count equals 7, you want to reset the count to 0, and you want to increment the row number to 24, because each chart goes from 0 to 24 cells. So when you go to the next row, you want to make sure you take whatever that row number is. In this case, it's 1, and then increment it by 24. There's going to be 5 different rows. So each time you get to the number 7, it increments the row number by 24 cell spaces, and it resets the count at 0, so that it can put each chart into Excel at every interval that's in this cell dictionary. So I'm going to run this. This is the function to save the data to the Excel file. It takes in a list of dictionaries and a save path, and you call with pd.XlsxWriter. This save path /ROI summary.XlsxWriter, and then we have a list of tabs: region, property, month, and city. This corresponds to the heat maps that I created earlier. So here's a list of those heat maps, and you can say for A, B, and zip these two lists together. You can call A, which is the heat map, which is a colored data frame, a styled data frame, A.2XlsxWriter, and then sheet name is equal B. So this is the data frame we're writing. It's actually your style object, because once you color it, it's no longer a data frame, it's a style object. So we're taking the style object and we're writing it, and the tab is going to be whatever's in this list, and these correspond to each other. Next, I'm defining a workbook, which is equal to writer.book. Then I'm defining a list of dashboards, and I'm adding the workbook.addSheet with each of these as titles for each sheet that I'm adding. And then I'm adding each of these workbooks or these worksheets to this list. And then for each item in this list, I'm setting the zoom to 36. Then I'm defining a list for names of the tabs for each of these dashboards. This is the list of the tabs for the reference tables. And then I'm saying for each ABC in this dictionary list, this dashboard list, and this ref list, I want to insert table with everything that's in this dictionary, and the names are going to be, the names of the tabs are going to be everything in this ref list. Then I'm going to insert charts with everything that's in this dictionary list, and the dashboards that I'm inserting them into is everything that's in this dashboard list. The workbook, I'm using this workbook that was defined here, and the names, or rather the tables, the names of the tabs from which the reference tables are referenced to populate the charts are in this ref list. So A, B, C, insert tables from A, and then call the tabs everything from C. Insert charts that are from the tables in A. You're inserting them into the dashboards that are in B, and you're referencing the tabs that are titles from everything that's in the list from C. This function is a function to save records to JSON files. So here's a list of the columns that I want to export to my JSON files. Here what I'm doing, just declaring total rows as 0. This is just to make sure that I get the total number of rows in the data frame. Like right now, the data frame has 28,784 rows. I just want to make sure that when this is finished, that total number is equal to the number in the data frames. So I know that I've saved everything to the JSON output. I'm declaring a dictionary called year. That's an empty dictionary. For each value in the main data frame at year, for each unique value in the year field, I'm declaring an empty manager dictionary. And then for each unique value in the regional manager field, I'm declaring an empty rep dictionary. And then for each value in the city rep field, I'm going to get a data frame that is equal to the current year, the current regional manager, and the current city rep. Then I'm going to take everything in the date field and convert it to a string, because right now, I'm going to do something. Everything at date is a datetime object. If I do at 0, you'll see this is a timestamp. You cannot save timestamps to a JSON object. So you have to convert everything to a string before you save it to a JSON object. So I'm converting everything in the date field to a string. And then I'm saying whatever this data frame is, if that data frame is not empty, I want to get the number of elements in that data frame, and I want to add that to my total rows. And then I want to get that data frame, but only at these fields here. In fact, I'm going to show something. So this is my data frame, and we have 15 columns. But if I put this list inside of my data frame, it only returns the values within this list. So now this data frame has only 12 columns because I'm only specifying that I want these fields. And these are the fields that I want in my final JSON output. So you set that list of fields to the data frame, and then you convert that data frame into a dictionary. This is very important. You have to orientate it. You have to orient it by records. So this rep dictionary at whatever rep name we're at in this loop is going to be set equal to a dictionary of this unique data frame, right? So for the unique year, unique manager, and the unique city rep, assuming it's not empty, we're going to set that to the individual rep. Then we're going to take that rep dictionary and we're going to add that to a dictionary and set it equal to the value of the manager for the particular manager at this point in the loop. And then we're going to get the year, and then we're going to take the string value of the year, because when you try to export something to JSON, the key cannot be a integer. It must be a string. So you take the string value of the year, and that becomes the key for the manager. This manager is a dictionary that's composed of city reps, and this rep is a dictionary that's composed of all the reps. It's composed of a dictionary for each rep in this loop. And then when I run this, it's going to take just a little time. Okay, that's done. So everything is in this year dictionary. It's going to take a little while to run. Okay, so this returns a dictionary. But that's not what we want. We want to take that dictionary and convert it to a data frame. So when you put a dictionary into the pd.dataframe function, you have to make sure you call that dictionary .items. And then you have to specify the columns that you want. This dictionary is going to return 2 columns. But the first is going to be the year, and the second is going to be each of these manager dictionaries. So I'm going to call that first field year and the second field regional manager. So I'm going to run this function here, and I'm going to set that to capital DF. And I'm going to call this DF. Now we have a data frame. It's composed of each year in our original data frame. this is our original data frame with 28,000 or so rows. This is the JSON output that we're going to be saving to JSON files. It's going to be composed of a year, a regional manager, and then each regional manager is composed of a dictionary that has each city manager, and then each city manager has a list of records that correspond to the particular year, the particular regional manager, the particular city rep. So here I'm calling this function to create a JSON output folder. When I run this, it's going to create a new folder called JSON output. And I'm defining this function here. In fact, I'm going to do this later. This function, save to JSON. This function takes in a data frame, which is going to be the big DF that we just defined over here. And then for each unique value in the year field, we're going to filter only for that year. And then we're going to take that particular data frame and then convert it to a JSON object. So we're going to say JSON equals DF at year equals the particular year. That returns a Boolean series. Set that equal to the original DF, or that the DF that's in this argument. And then we're going to say JSON.toJSON orient equals records. This returns a row of records. And then that we're going to set that value back to the JSON variable. Then we say with open destination. I see. That's why I did that. Okay, how about this? Destination. Okay. So here I've added another argument, and this is going to be the destination. It's going to be that folder path / real estate sales - the year JSON data. W equals write. So even if there are already files there, it's going to write over it. And then you're going to call as f and then f.write this JSON object. Okay. So when I added this argument here, it means I need to add this argument here. So I think if I just put this here, this should work. Remember from earlier, this is the function that I used to create a new folder. I used it to create this sample folder. So if I'm going to run this again on something. So I'm going to call this, we're going to call it sample2. Sample folder 2. When I call this function, it should create a new folder here called sample folder 2. There we go, sample folder 2. Oh, I misspelled that, sample. And it returns the base path for that folder. It returns a path, the full path for that folder. So the parameter here is taking in a path and then / real estate sales data. Okay, so here, if output JSON, as you can see, it clearly doesn't exist here. If it doesn't exist, it creates that folder and then it returns a string for that path that can be used as an argument in this with open statement here. So I'm going to delete this, and I think this should work. So this is going to save our JSON output to output JSON. And then here we have a list of the summaries that we need to call in our save data function. Each of these summaries were from the function defined earlier, and it's going to return a dictionary of aggregate tables. And each key for that dictionary is going to be the year and the region. And then you're going to take that list, put it as a parameter into the save data function, and then call this function, dir output return on investment. And as you can see, that folder does not exist, so it's going to create that folder, then return the string path of that folder, and then use that as an argument in this function. So I'm going to run this. And we see now we have output ROI, and I'm going to run this. We now have output JSON. And if you look in here, we have an Excel summary. And then here we have a record for each year for real estate sales data. So open this up. And we have the year, which is 2011. And then you have a list of regional managers. And then each regional manager has a list of city representatives. And each city representative has a list of records that pertain to the year, the regional manager, and then this particular city representative, and then every single one of the values for that record. And then this is the Excel output. And here we have a heat map for region and year. And as you can see, return on investment is greater outside the Californias. Return on investment is greater for residential properties. Return on investment is greater for the months of 6, 7, and 8. And return on investment here seems to be greater for everywhere but Los Angeles, New York, the Bay Area, California, so on and so forth. And then here we have a dashboard that's representing profit loss by quarter. So every row is each year, and every column is each region, and each chart is the profit loss number for that particular year in that region by quarter. As you can see here, 2011 profit was 162 and the loss was 149. So for every single sale for that quarter, for that year, and for that region, there were 162 sales that resulted in profit and 149 that resulted in a loss. And here is the return on investment by quarter for each year and for each region. Here's a return on investment by month for each month, for each year in each region. And then you have a average return on investment for each month. And then you have return on investment by property type for each year, each region, and then each property type. There we go. So this is 7 times 5, which is 35, and 35 times 3 is 105 maps, or charts rather. So 1, 2, 3, 4. 35 times 4. 35 times 4 is 140 charts. So in about 47 minutes, I've gone through the code that it would take for you to generate 140 charts. It would be very difficult to do this just using Excel. Using the Pandas library and XlsxWriter makes your job a lot easier. And here are the reference tables. Each reference table corresponds to a particular dashboard, so it's populating a particular set of charts. The last thing I'm going to do is delete the folders that I created. I'm going to save this and then exit. And I'm going to delete my JSON output, the ROI, sales data, sample. Oh, don't delete sales data. Sample folder. There we go. So I'm going to go back in here. And I've declared a start variable up here, as well as an end variable down here, so that I can print the amount of time that it takes to run this all this code to generate the heat maps and the 140 charts, as well as the reference tables. And actually, what I'm going to do right below this is print total rows, as well as df.shape at 0. This should print the total number of rows that we processed in this code here, and then this is going to print the shape of the data frame that we read in to make sure that these two numbers are equal, so that we make sure that all of the data was properly saved to the JSON output. This could take up to about 30 seconds. Okay, that took about 18 seconds. And down here we see that total rows equals 28784, and the shape of the original data frame is 28784. And we have our JSON output and our return on investment output. If I go in here, we have our Excel sheet. And I go in here, we have our JSON data for each year, and then each regional manager, each city rep, and then each city rep has a series of records. And then everything here is the same as it was before. And it took 18 seconds to run that code. So theoretically, if you got a folder with text file data that you needed to process, if you had a similar, if you had to process information, depending on which bits and pieces of this code that you use, you could write the code, you could generate heat maps, charts, and reference tables, and it takes approximately 18 seconds to run every single time. This has been my demonstration of my code for automating reports with the Pandas library. I hope it has been informative. Goodbye.